In this video, we're going to talk about cumulative distribution functions. The cumulative distribution function, or CDF, these functions are used to calculate the area under the curve, specifically the area to the left of some point of interest. Now these functions, they're used to calculate the accumulated probability. Now keep in mind, whenever you have a continuous probability distribution, the probability is equal to the area under the curve. And since the maximum probability is 1, the total area under the curve will be 1 as well. Now, probability density functions are different from cumulative distribution functions. The PDF, or probability density function, is f of x, and it tells you the shape of the distribution. So for instance, let's say if we have a uniform distribution. In this case, f of x will equal a specific number. It's going to be a constant value. F of x is going to be 1 over b minus a for a uniform distribution. It's a number. It doesn't have the variable x in it. You'll see something that looks like this. So this is f of x, and it varies from a to b. So this right here is the PDF. That is the probability density function for a uniform distribution. It's equal to f of x. Now the CDF, the cumulative distribution function, will give us the area under the curve to the left. So let's say the point of interest is x. The CDF will give us the area to the left of x. So the area of the shaded region in blue. Now, this is basically the shape of a rectangle. The area of a rectangle is the base times the height. Notice that the base is the difference between x and a. So it's x minus a. The height is f of x. And f of x is what we see here, b minus a. So the CDF, the cumulative distribution function, will give us the area to the left. So we have this formula. The probability that the random variable capital X is less than or equal to some number is going to be x minus a over b minus a. So this function right here, highlighted in blue, this is the CDF. That is the cumulative distribution function for a uniform distribution. It gives us the area to the left of some value x. And the PDF is just f of x. For uniform distribution, that's 1 over b minus a. Now, let's talk about the exponential distribution. Let's discuss the CDF and the PDF for this type of distribution. The exponential distribution, the maximum value is the y-intercept, and it decreases over time. The maximum value is also known as lambda, the rate parameter. The probability density function for an exponential distribution is going to be the function f of x, which describes the shape of the distribution. And f of x for this particular distribution is lambda e to the negative lambda times x. And lambda is the rate parameter. It's 1 divided by the mean. So this is the probability density function. It tells you the shape of the graph. That's what it does. In addition, it also gives you the height of the curve above the x-axis at some point x. That's another thing that it tells you. Now, the CDF gives us the area under the curve to the left of some value x. So let's say if we wish to calculate the area to the left. So that's going to be AL. That's going to be the probability that x is less than or equal to some value, and that's going to be equal to 1 minus e to the negative lambda times x. So that is the cumulative distribution function. It gives us the area under the curve to the left. So if we wish to calculate the probability that x is between 0 to x, or let's say 0 to a, this function will help us to get the probability. It's equal to the area under the curve. Now, what if we wish to calculate the area to the right as opposed to the area to the left? We know that the total area is 1. So the area to the right plus the area to the left must also be 1. So the area to the right is 1 minus the area to the left. And we know the area to the left is what we see here. It's 1 minus e to the negative lambda times x. Now, if we distribute the negative sign, that is this negative sign, it's going to be 1 minus 1, and then these two negative signs will cancel, giving us a plus sign. So plus e to the negative lambda times x. So 1 minus 1 is 0. Thus, the area to the right is going to be simply e to the negative lambda times x. Now, this is not the cumulative distribution function because it doesn't give us the area to the left. It gives us the area to the right. So the CDF is what we see here. That's the CDF for an exponential distribution. Now, let's say if we still have an exponential distribution, but we want to calculate the area between a and b. So we want to find a probability that x is somewhere between a and b. How can we calculate the area under the curve between those 2 points? So this area, highlighted in blue, is equal to the probability that x is between a and b. And that is the difference between the probability that x is less than b minus the probability that x is less than a. So these are areas to the left. So we could use a CDF to calculate the probability that x is less than b and the probability that x is less than a. The probability that x is less than a would be the area shaded in red. The probability that x is less than b would be the area shaded in green. If you subtract the area shaded in green minus the area shaded in red, you'll get the area shaded in blue. So, using the CDF function, we can replace that value with, this is going to be 1 minus e to the negative lambda. Instead of x, we're going to replace x with b. So this will give us the area to the left of b. Now we need to use the CDF function to get the area to the left of a. And that's going to be 1 minus e to the negative lambda times a. So this is how we can calculate the probability between a and b using, or if we have an exponential distribution. Another thing that you want to keep in mind is that for a continuous probability distribution, the probability that x is greater than or equal to a, and less than or equal to b, this is the same as the probability that x is between a and b. So you want to keep that in mind. There's no difference here. Another thing that you want to keep in mind when dealing with continuous probability distribution functions is that the probability that x is a single value as opposed to an interval of values, let's say the probability that x is equal to a, that's going to be 0. The only way to get a value greater than 0 is you need a range of x values. Because at x equals a, all you have is a line. You can't really calculate the area of a line because you have height, but there's no width. So therefore, you can't calculate the area. The probability that x is exactly a is 0. So just keep that in mind. To review, remember the PDF, the probability density function, is f of x. It tells you the shape of the graph, if it's an exponential distribution, a normal distribution, or uniform distribution. The CDF, the cumulative distribution function, it gives you the area to the left of some value. It can give you the area to the left of A or to the left of B. But it gives you the area under the curve, which is the accumulated probability up to that point. So that's the difference between the PDF and the CDF. Thanks for watching.